Hello, thanks for joining me again. Last video, we went over our studios, the layout of our studios, um, and the different panels of our studios just to get a better familiarity with the program. In this video, we're actually going to delve deeper into R, the programming language, and the general fundamental principles of using a programming language like R. So first thing we're going to do is open up our studios. And instead of going to the application in the dock like we did last time, just so we can practice our skills, I'm going to go to Finder and go to the folder and file that you have for the R project that we made last uh, lecture. And to open up the project, you're just going to click on this file here, and it's actually going to open up R back to the exact workspace that you had set up when you saved it last. So we'll just wait until it opens up. And as you'll see, this is the standard R Studios layout. However, you'll notice that there's no R script panel. They only have the console. And that doesn't matter for this one because what we're showing and doing in this lecture, you don't really need to save. It's kind of just like an introduction to the fundamentals of programming and coding. So at its base, at its most lowest level, what you're doing with coding, with really any type of software, not just R, is you're giving the program an input, and this can be a single number, or it can be a whole data set, the whole data table. Um, you're specifying a function, and this is going to be the action that the program is going to do on the input. And lastly, you have an output, and that's what the program is going to give back to you once the um, function has been executed. So those three things: an input, an function, and an output are the fundamentals of coding, and is how you should think about coding when you're writing it. So I think the best way to really show this is by doing an example. So let's just say you wanted to find the arithmetic mean of 6 readings of a patient's blood pressure. Let's say their diastolic blood pressure. And let's say, so the readings were 80, 78, 81, 80, 76, and 82, or 83. Let's do 82. And so instead of, adding it up, dividing it by hand, what you can do is use the function that is in the most base R, so without any other additions and add-ons. R itself has a function called mean, and so we have our input here, these 6 values, and our function mean. So to set it up, we're going to make this a vector. A vector is a list of either numbers or values that have a character value. So it could be like A, B, C, D. So that would also be, you can also make that into a vector. Which is one unique thing about vectors is that they all have to be, every value in it has to be the same type. So you can't have a number and a letter in the same vector, but there's ways of organizing together in different ways that we'll talk about. But the way that we'll format our input is we're gonna make a vector by writing C parentheses and then a parentheses after the last number as well. And in between each number, you have a comma that lets already know that these are different values. So we have our vector, so we have our input, and now we just need our function, which is the mean function. And the mean function takes in the input it requires is either a numerical, either like a list of numerical numbers like we have here, or just like a numerical number. And when you press enter, you get the output. So this is the output here. So 79.5. So that highlights the three main components of coding. However, there's an easier way to do this, a more succinct way of doing this. And it incorporates the next thing I want to talk about, which is a storage object in R. So a storage object in R can be a single number. It can be a vector like this. It could be a graph. It could be a data table. It could be all different types of values and structures in R, and it's represented in a single object that you name, and it's done in a very simple way. So the way that you create a storage object, instead of having to write out or in our case, instead of having to write out this whole vector, is by first writing the name. So when you're coming up with a name for an object, you want it to be pretty descriptive, so you know what you're talking about when you come back to the code. So we'll say diastolic blood pressure, and then we're gonna make diastolic blood pressure the vector that we came up with. So it's gonna be the list of the 6 values. So just to save some time, okay, copy, paste it. So it's the way you're gonna do this is you're gonna write the name of the object that you want to create, the storage object, less than symbol, and then a dash, and then follow it by the value that you want to give the object. So now we're going to highlight it, or I think you just press enter. And now you'll notice that this is our input, and this is the function, which is assigning us an object. It didn't create a output in the console. What it did is, I don't know if you noticed, but on this top right in the environment, it made a storage object called DSDP, and in the environment, it shows that this object, it keeps track, basically the environment keeps track of all the objects you have. So here is the name of the object. Here are, this is the form of it. So it's saying it's a numerical vector of 1 to of 6 values. It's just saying like 1 to 6. This is just saying that this is the order. This is 1, 2, 3, 4, 5, 6. And these are the actual all the values within the vector. So now that we have this object, we could, instead of having to write this all out, we can just do mean and then do DSDP, and we should get the same answer, which we do. And now, finally, if you want to store that answer, and not, because when you do this, the output that you get from the code doesn't get stored anywhere. If you want to store it, like we stored the vector of blood pressures, we can store it just the same way. So let's say for this one, we'll say average. We'll name we'll store the answer or the output as average BP. and then do the assigning an object symbols, and then we'll do just this code again. So now the object, this output as an object. And if we wanted to see what that is outside of just it being in the environment and you want to interact with this object, you just do average VP, press enter, and this is the output. So you can use objects in a way to really shorten the amount of code you have to write. And if you know you're going to be doing an input and a function repeatedly, or a very similar one, you just will come up with a storage object, so you don't have to keep writing the input out all the time. And I just wanted to show you just the diversity of what a object can be. I'll be just showing you quickly how an object can be a data table. So built into R, another thing built into R is a data table called Iris, which is a data table of data on flowers and like their petal length and different features and the species. And it's a way for people to practice. So all I did was just press enter and it printed out the entire data set. So instead of it going into the console, like I said, you can just assign it to a storage object. So let's do iris object, and then do iris. Now we have this data table that is stored, because it's also an object, it's still stored in the environment. And if we click on it, R Studios has a feature built in that you could actually see a data table in this top left corner where the script is usually, and it's much more presentable than when it's in the console. So that's really it with the code. However, I do want to now that we've kind of gotten a little familiar with code, the structure of code, and what functions are, I want to introduce the set of functions that we're mainly going to be using in this course. And they all come from a package called Tidyverse. And I don't know if I mentioned it prior, but a package is a set of functions that people from the R community have made and share with other people, so that you don't have to make these functions by scratch if you're doing a similar thing. Like if you're making if you're doing a GWAS, like you can download someone's package that has the code for a GWAS. So similar to that, there's a lot of data cleaning tools and data presentation tools that have been compiled into this one big package called the Tidyverse, which is really like 7 or 8 packages together. And we're going to be working out of that predominantly throughout this course. So to install it, you're going to type into the console, install .packages, and by the way, everything is free. So install .packages, and then you do parentheses, Tidyverse, all lowercase. So it's TIDYVERSE, and no uppercase, no space, and you're gonna click enter. I am not gonna do it because I already have it installed and it kind of like delays the code, but you're gonna click enter, and then when you do, you might be at keep track of the code that pops up, because it's eventually going to ask you if you want to include a certain code or data, and just say yes, type in yes, press enter, and then it'll it'll continue and you'll get the packages. But once you install Tidyverse, it's now on your computer. It's going to be accessible to your RStudio application. And whenever you want to load up those functions, because it's not in the base R that gets loaded up when you open RStudios, you have to just click library and then type in the package that you want to bring into RStudios and activate. So we're going to type in Tidyverse. This time we don't need to write it in parentheses, click enter, and now you'll see a bunch of code pop up, and it's basically like activating these codes and including all the functions into the, I guess, working space, so that, like, let's say you wanted to call up one of the codes, it'll pop up. Whereas if you didn't load this, you couldn't use certain functions like ggplot, which is going to be the main functions we use to actually make graphs on RStudios. So there might have been a lot of information at once, but if you can really get a grasp on the core fundamental idea of coding, which is giving the computer an input, telling it what function to do, and receiving an output, then you've kind of really made a step forward. And in the next video, we're actually gonna start getting into the real coding and how your experience might be if you're coming back from lab, or you have a project and you need to start looking at data, just like what the steps are going to be from bringing your data from a file that was sent by, let's say, your PI, and putting it onto R. We're going to go over that tomorrow or the next video. And yeah, it's very excited to actually get into the coding aspect. And I hope you guys are enjoying this. Thank you so much for watching.